health checks in an ASP.NET Core .NET 8 application. How do we add them? Why do we want to add health checks? And how do we hook up those health checks to our Azure services, a web app or a container app? Now for the why, it's really simple. The health checks will improve the resilience of your applications, of your services, and it will also, it's one of those things that you need to do to make your services more production ready. So let's start off by having a look at how do we add the health check, because it's super simple. You barely need to write any code at all. Okay, so let's just jump in. For a basic health probe or health check, this is the code that we need to add right here. I'm just going to cut and paste it because that just makes it that a little bit easier. So in the builder section, let's just move all this stuff here out of the way. It's not important for what we're trying to do. Okay, so we're going to add health checks. Okay, cool. And then we're going to, okay, let's actually not be lazy and type map health checks and health Z. The Z is like a standard from the Kubernetes community. So I'm just sticking with it because we're going to be running our application on a container app, and the underlying technology of the container apps is Kubernetes. So just sticking with a community standard there. And let's run it. Let's see if we get a health check endpoint and what the result looks like. What I might do for next time is I'm going to change my launch settings because this will make it a little bit faster. And if I go into Docker, rather than running the Swagger, I just want to go straight to the health endpoint. All right. That took about 20 seconds. I just paused it whilst it was doing its thing, warming up. There is our endpoint, the healthz. It actually automatically, it did pick up that launch setting that I made. And it's saying that, okay, yep, we're healthy. So what is it actually checking? All it's checking at this point is that the service can respond to a request. But it can do so much more. How much more can it do? How many checks are there? Well, it's a fairly extensive list. The link to this is in the show notes, but you can see here there's checks for a bunch of AWS services, Azure services, different data stores, anything, pretty much anything that you might want to do a health check on, there'll be an existing check for, and if not, it's not difficult to roll your own. And we'll take a quick look at how to do that before the end of the show. So a very common check that we might want to add is checking the SQL Server, if we can connect to our SQL Server. So the way we're going to do that is it doesn't come with ASP.NET Core out of the box. So we need to add the NuGet package to check for SQL Server connection. So we'll go to the package manager console, the NuGet for SQL Server health check. Go into there. Okay, and the package manager, I'm just going to copy the command and run that here. That's going to install the NuGet package so that now when we do our health check, we can add a SQL Server health check. And we don't need, it's interesting, we don't need to write any logic ourselves to verify this. What we need to do is provide the connection string, and and a query that we want to run, which is typically a recommended approach is to use select one. So our connection string we can find by using this. So we'll just go to our builder to get the configuration and connection strings. And there's a particular connection string that we want. So let's just take a look in the app settings. Don't have a connection string here yet. So I'm just going to cut and paste that in there. So now we've got connection strings and one called action now DB. So we'll just go back here. So that's going to give us a connection string. Then the next thing is what query do we want to use? And we're just going to use select one. We don't care about actually returning any data. We just care that a query will work. All right, so that's our query. Something very simple. And I think that's all we need. We can add tags, except but we're going to leave the tags off for now. So that should now test our SQL Server connection at the same time. So I'm going to run it and see if we're still healthy. Can we connect to the database? And then we'll change it so that we can't connect to the database, and we should see that we're unhealthy. The other way around, and we're seeing that it's unhealthy. Now note here that with this unhealthy, we can't actually tell why it's unhealthy. I mean, we know that it's because of SQL Server, because that's what we've just added. But if you were running this in a production system and there were several things you were checking, this just tells us something's wrong. It doesn't tell us what is wrong. And we'll look to improve that shortly. But for now, let's see why we're getting unhealthy when the database exists and we're doing a very simple query. Maybe there's something wrong in the connection string. So let's just jump into here. Now, because we're running in a Docker container, we can't just use localhost or what you would typically use when you're connecting locally is you just use a dot, but it's running in a Docker container. So we can't use the dot. And the way we determine what IP address we should use when running locally is with ipconfig. So we're just going to do that in your favorite command line tool. And this is the number that we need. So let's just change this 172.23.80 and 1. It'll be different on your machine. And that number that was there was the IP address before I did a reboot this morning. So it will change on your local machine as well. So just remember that. Okay, so I'm going to save and restart. And let's see if we are now healthy. Not healthy. Okay, what else could be wrong? Let's take a look. So that's the database name. Password is the wrong password. Okay, so I'm going to change this to the right password and then give it another shot. Healthy, now that we've got the right password and the right IP address. So we are configured correctly and can talk to the database. Okay, but this healthy, this is the default. And like I said before, it's not really giving you enough information if you're quickly trying to figure out why a service isn't working. And usually when a production system is down, you want to find out fairly quickly what the problem is. So simply unhealthy isn't enough. So how can we improve it? That is in our add health checks here. There's some options that we can add. So new health check options, not null, new health check options. And what we can do here is change the response writer. And the default for the response writer is just simply that plain text. Again, you can check that in the source code because it's open source. But what we're going to do, I've prepared something beforehand and created a health check response writers class. Actually, that should probably be static. Just a couple, there's only contains a static thing. I'm not meant to create instances of this. And it has a write response. I might just call that write JSON response actually. And this is not written by me. This was taken directly from the Microsoft page. So you can go and grab this yourself. Nice and easy, just copy. And the difference is, let's go and set that as our response writer. So be a health check response writers, write a JSON response. Now let's see what this looks like. Okay, much better. So we've got status of healthy. We can see that there's a SQL Server result. The SQL Server is healthy. No information there, but we haven't added anything to populate that. Okay, brilliant. So what happens if we change this back so that it's not correct anymore? So I'll just change my IP address to 2. So this time it will fail to find the database. Now that took a bit longer because it had to reach the timeout limit, but this is a much more helpful unhealthy, because we can see that, yeah, okay, we are unhealthy, but what is it that's unhealthy? The SQL Server connection is unhealthy. Now, obviously, this is just one. We're only checking one thing here, so it actually isn't all that helpful. But if we were checking a handful of things, knowing what we are failing to connect to, what is wrong, yeah, way more helpful. So that's a worthwhile thing to do, adding in your JSON response writer. And you can customize it, of course, to how you prefer it. What about our services that are running in the cloud? How do we take advantage of these new health check endpoints that we've created and added to our service? One thing to note before going any further is I've commented out the SQL Server check. It's not going to help us with looking at the cloud. I don't want to go in and set all that up so that it actually succeeds. So it's been removed. All we're doing is checking that our service does respond to requests. Okay, so do they respond to requests? Okay, so he's healthy and so is that one. So they're both working, and as you can see from the results, the SQL Server result has been removed. Okay, it's helpful to be able to hit that endpoint and just see when we're troubleshooting, but really what we want, how we want to use those endpoints is automated so that our services are resilient without human intervention. So how we do that on a web app, web apps have a health check. And okay, so I'm currently running on the free service. I'm gonna have to scale up to a basic one or higher in order to use the health check. I'm gonna do that now so I can just show you how to hook this up. So that's in the scale up. Get onto the B1 level. It's the minimum level for the health check. I'll scale it back down again after the demonstration. Always remember, if you're doing anything this kind of testing, scale things back down. Remember to scale it down or you're going to get hit with costs. And on a development server, the free level is probably going to be enough until you start adding more and more features that the app service allows. Okay, so that's scaling up. It'll take a couple of minutes. Whilst that's happening, let's take a look. How does it work on the container app? Because the container app actually has three different options. We've got these health probes here, and you can see there's a liveness probe, a readiness probe, and a startup probe. And they're all disabled. We're going to enable them, but before we do, I just want to draw your attention. This blog post, there's a link in the show notes. I like the approach that Andrew prefers here. He uses dumb liveness probes, smart startup probes, and readiness. I'd suggest start with dumb and you can improve from there. So smart is going to check that the dependencies that your service has can be reached, so are working. Connectivity is working, so you can connect to the database, you can connect to your service bus, you can connect to the API, you can reach it. Dumb, it's really just checking that it can respond to requests. Your service can respond to requests. So when we do a startup, we want to make sure that we can connect to everything that we need to connect to. But when we do a liveness probe, which happens like every minute typically, we really just want to make sure that the app is responding. And this blog post is excellent because he goes into some depth as to why you should use the dumb versus smart. And it makes a lot of sense to me. So that's the approach that I would suggest as well. There's a key takeaway here as well. Things that you're going to check in the liveness check, only put them there if a restart might fix the connectivity. If you can't connect to a database, it's probably not because the service has something wrong with it. It's probably a network problem or a database problem. So restarting the service, and ultimately will be all of the instances of your service, isn't going to help and is probably going to be more disruptive. In those cases, what you probably want to consider is, well, maybe making an application change to have a fallback. If it's critical that that call does something with the request and it can't reach the database, maybe it needs to drop that request into a service bus or a queue somewhere to be picked up later. But that's an architectural thing you need to decide for your application. All right, so next, let's just very quickly address what is a liveness probe versus a readiness probe and a startup probe. So the startup probe, as the name suggests, it's only going to be called when the application starts up. When it returns true, then the system knows that your application has started up correctly, and it can connect to all the things that you've specified that it needs to connect to. The liveness probe and readiness probe, they're going to be just indicating that your application is still alive and is responding to requests. You can add other checks in there, and you can add your check to see if you're connecting to the database successfully. I would just not recommend it. So what does it look like to configure that on a container app? So we need to go into Edit, select your instance of the container app, go into Health Probes, and from here we can enable these checks. So once we've enabled them, we're going to have to add a path. Now in the code, we've only got one path, and that is this healthz path. So let's add two new paths so that we're also so that we have a different URL that we can hit for the startup and for the readiness. That's the liveness and the readiness. So I'm just going to cut and paste that in there. So we'll keep the healthz endpoint, and that's going to do, we're going to use that for our startup, and it's going to do all of our checks. For liveness and readiness, if you set this predicate to false, it's not going, any health checks you've added up here won't be included. So this is the dumb test that we're doing. Just going to check that it can respond to requests. All right, so I'm going to save and deploy that so they're an option for us. So that change has been deployed to the container app. I didn't worry about deploying it to the web app because we only need one endpoint there. So now we're going to look at how do we use those, how do we set up using those endpoints, just using the Azure portal for now. So for the liveness probe, we want to hook up to our liveness endpoint. So I'll just go liveness, double check your port, make sure that it's using the correct port. So in our Docker file, I think I've got that open here, we're exposing port 8080, which is the default for HTTP requests. So we're going to continue to use that. For everything else, I'm going to keep the defaults, and I'd recommend you keep the defaults until you discover a need for your system, for your way that the application runs. Make the change when there is a need. Okay, so that configures the liveness probe, readiness probe. So coming back to our program, it's just readiness. So the path, whoops, what did I do there? Closed it off. The path is readiness, port 8080, leaving the defaults. And finally, startup will enable the startup probe. And for that one, we're going to use the healthz. Again, keep all the defaults, click save. Now, in order to get a new version, we'll need to create a new revision. So that's going to go off and do that right now. Okay, let's just try that again. Okay, successfully deployed a new revision. That's underway. So what about a web app? Okay, so we've changed the instance type, the instance size to a B1 so that health check is an option. Just click enable, and then we go, okay, what's the path? Healthz. I didn't deploy the liveness and readiness change, so the healthz path is all that's there. Now, then we've got, when do we, unhealthy instance removal, how many minutes? So how long should the load balancer receive unhealthy responses before it tries to kill the instance and replace it with a new one? So again, yeah, you keep the default. If this is one of the cases where I'd probably recommend reducing it, go 5 minutes. For an app service, it's only going to restart your app a maximum of 3 times a day. So consider that as well. Okay, so that's enabled. We do that and we'll click save. So coming back to the container app, that's probably finished now. Take a look at our container. Take a look at the health probes, and we can see that that is all configured. All right, now coming back to the web app, there's a warning here which is worth paying attention to. We're currently running only a single instance, so that instance won't be removed if it becomes unhealthy. However, after an hour of continuously receiving unhealthy pings, it will be replaced. So just be aware of that. Obviously, it's better for the load balancer if in production, you're normally going to be running at least 2 instances. And so you won't get this warning. And if one of those instances goes into a bad state, it'll get bounced effectively. All right. Before we wrap up, what if we needed to implement our own health check? There's a couple of ways you can do that. First, way you can do it is inline. Just simply add a check, give it a name, and then whatever your logic happens to be. So in this case, this one will just return the fact that it's always healthy. Another thing you can do is for your custom health check, implement the health check interface. Then once you've put your logic in there, it's just simply adding another check for my custom health check. And then this will need a name, my custom health check. That'll do for now. And okay, so if you're going to create your own custom health check, I strongly recommend you take advantage of the fact that .NET is open source. There's a link in the show notes for this page. You can come here, find an existing health check that's been implemented that is as similar as possible to what you need to have your own custom check do. I'd be surprised if there's not an existing one, but you might want to add your own functionality as on top of what is in here. So that could be a reason why you want to implement your own. But use this as the starting point. So take that code, put it in your own custom one, and then do the modifications that you want. That would be my suggestion. Of course, you do what you need to do for your service. Okay, now the other thing is another place you can use your services, these new health check endpoints is in your pipeline, your deployment pipelines. So for example, for an Azure web app, you can have background slots called staging slots. You deploy to your staging slot, then you can check that it is healthy, that it is ready. And then once you get that healthy response, then you can perform the slot swap and not before. So today we've looked at implementing health checks on our services to make them more resilient and more production ready. So what I'd suggest when you're getting started with this is, like with most things, keep it simple. Just implement what you need to begin with. And I'd suggest all you need to begin with is those dumb checks. Get that deployed, get that working, and then add more improved, better checks like database checks, storage account checks, service bus checks when the need arises. Start simple, learn, improve, and iterate. So good luck implementing your health checks, and be kind, be curious, and go build something great.